Hey guys, so here we are. We're going to try to uh, do this as a makeup since we missed Thursday again. I'm not for sure how perfect it's going to be, but we're going to give it a shot. So before we get started, I wanted to let everybody know we'll be covering lessons 85 through 89. And before we get started, you need to make sure that you have your normal packet that we do during class, which will have been emailed to you, along with a handout that I had made up for y'all. That both of those should be available in your email. So have those printed off probably before you start this. Of course, you might want to also make sure you have your calculator with you. You'll need that. Um, and have your book handy too. So first I asked everybody to send me some questions that they have from the homework like we normally do. And I've got those ready, so I'm going to work a few of those. And then we'll move on and do today's lessons. Um, if I work faster than you need me to, because I only have Ryan here, so I won't be, of course, the time won't be wasted walking around the room. Just pause your video and work it, your problem, and then start the video again to see the end result on the answer. So as usual, just pause, you work the problem, and then if you want to see me work the problem, you can hit play again, okay? So I had a couple questions. I didn't have any questions from 82. I did have questions from 83. And we're going to, I think even before I work these homework problems, I'm going to do the review that I intended to do with you, and that might actually help you with some of these problems that you had from the homework. So I'm going to start with your review sheet that I gave out to you. And the first page is all the couple lessons that we have covered so far with different ways to factor. And way back in lesson 80, we started with a very simple problem that they gave you of something that looks like this. Now this is an old one that we started with. So when we first started this, we talked about having to find the common GCF, and this method we refer to as factoring the GCF, greatest common factor. And that means that we look first at the coefficients and we decide what is the biggest coefficient that can come out of both of these. All right, and I told you a little hint, always check to see if the little one will go in the big one. If the little one goes in the big one, then we know that that is the biggest coefficient that can be used. 2 does go into 4, so it is the biggest number, so we pull that one out. We then look at our variables here. We have x cubed and we have x squared. We need the biggest one that will go into both, and here it would be the x squared. X squared will both go into the x3, x to the third, and x squared. So we pull that one out as well. And we set up, remember the whole point of this is to get it into the something times something format. If we're in something times something, that means we can do some good things with that. So we've got the first factor here factored out. That's our greatest common factor. Now we need what we're going to multiply it by. This is our answer. We're essentially asking ourselves what multiplied by this will give me this. I have 2x squared. I need 2x cubed. In order to get to the 2x cubed, we need another x. The 2's are good, but the x is missing one. We must multiply it by x. Then we move on over here. We have a 2. We have to get to 4. We need to multiply that 2 by 2. But our variables are good to go. We don't need to multiply by anything else. Therefore, we were able to factor this, which used the plus sign, and we can't do anything with it, remember, into the factored form of something times something. And that was the very first thing we did in lesson 80. A couple lessons later, they made it a little more complicated for us, or a little harder. They gave it to us and made it equal to 0. Now that wasn't bad, because anytime we discovered, remember I told you that that made things a lot easier for us when we're solving for x, because we know in order to get 0 as the product, That means one of these two factors has to be 0. Something times something equals 0. Either this must be 0 or this factor must be 0. One or the other to get 0 as an answer. So when you look at this one over here, in order for this one factor to equal 0, x must be 0. That's the only thing we can make x. That will make, when we multiply it by the 2 squared and the x squared, that's the only thing we can multiply it by to give us 0. If we wanted these inside parentheses, that factor to equal 0, then we have a positive 2. That means that this x must be a negative 2. Okay, so if this was a negative, that would make these parentheses 0. And then we could have this times 0 would still be 0. So this is the old method, the very first introductions to factoring that we did. Okay, and just as a remember, this is a binomial. Remember, it has 2 terms in it. It doesn't matter how many numbers are in the group, but it is 2 terms being multiplied together. It's a binomial. This is a common way to factor binomials. All right, so that was lesson 80. Then we got a little harder. In lesson 83, which is on your page at the bottom of that page, we were introduced to trinomials. And they gave us something that looked like this. Okay. And at first, they didn't even make it set equal to 0 or anything. They just asked you to factor this. They called it advanced reverse distributing, is what your book calls it. Okay? And we learned in order to use this method to factor, first maybe you wanted to use your GCS method, that we just used. But when you go through it, there is no coefficient that's common with all of them except 1. 1 won't help us. And there is no variable that is common with all 3 terms. Therefore, we can't use that method. We need another one. The next method in 83 that was introduced showed us, well, let's do a reverse. What we want for 18 is to think about all the different factors that can be multiplied together to give us 18 as an answer. And those are wrote down on your paper there. If you were to do that, you remember you could do 18 and 1. That would give you 18, a positive 18. We're looking for a positive 18. That's important. But you could also do negative 18 and negative 1. You could also do 2 and 9. Or you could do negative 2 and negative 9, because a negative times a negative gives us a positive. You could do 3 and you could do 6. Or negative 3 and negative 6. All of those are possibilities that when you multiply those two factors together, you get an answer of a positive 18. But the second part of that method was not only did it have to total positive 18 when they're multiplied together, those factors, when they were added together, had to total 9. So you would look through that list, and I have them wrote down on that handout that I gave you. And if you looked at that list, the only one that would satisfy that was a positive 3 times a positive 6. Okay? When you find those factors, we're setting up for our something times something. Because it was a positive 3, is a positive 3 and positive 6. That's where that goes inside these parentheses to be the something times something. Now, if you took the time, I'm not going to do it, but you could sit here and go right back and distribute this problem out. X times x is 8 squared, and then you could have did the x times 6 and the 3 times x, and that would have gave you your 9x, and then 3 times 6 would have gave you your 18. If you distributed this back out, you'd be right back up here with this being your answer. Okay, so that was introduced to you in 83. Then I think 84, or maybe even was 83, they stuck a 0 on it. And again, the same thing applies as it did in the GCS method. Because it's equal to 0, one of these factors has to be 0. It's the only way we can get 0 as a product. If we wanted these parentheses to be 0, if we wanted this parentheses to be 0, then we would have to, x would have to be equal to negative 3. If we wanted this set of parentheses, this factor to be equal to 0, then that x must be negative 6. If you do not have your problem is not set equal to 0, they're only asking you for these two sets of parentheses. Only when it's set equal to 0 are they really asking you to solve for x. Okay? All right. Now, for your homework questions from a couple of these lessons. I had a couple questions from 83. The first one was number 6. And now I'm on lesson 83, number 6. I'm working a couple of the homework problems people had from. Hopefully it'll actually make sense now. All right, so here's the problem. We have x squared plus 5x plus 4. So your book's directions just say factor each expression. Notice that it's expression because there is no equal sign here. Because it's not equal to 0, we're not asked really to solve for 0. So if you ended up with opposite answers, like if you had positive answers and your answers were negative, that means you solved for 0 over here, so you went ahead and went just a little too far. Okay, this one just, because there's no equal sign or 0, they're just looking for you to put something inside parentheses. Okay, so the first step is to look over here at the 4 and write all the factors down that equal 4. And you could have did 1 and 4, negative 1 and negative 4, 2 and 2, and negative 2 and negative 2. All of these, when multiplied together, would give you a positive 4 when multiplied together. But the second part of that says when you add them together, it must total 5. This one won't do it. This one won't do it. And you look between these two. If you add these two together, you get a negative 5. So that answer is not correct. The only one that will satisfy the requirement of it equaling a positive 5 is the very first choice, 1 and 4. That's a positive 1 and a positive 4. So that's x, positive 1, x, positive 4. And this was your answer that the book was asking for. If you got a negative 1 and a negative 4, you just took it a little too far. You took it all the way down, assuming it was 0, and they asked you to solve for x. All right. The next one on that one that was missed was number 9. That was an easy one. This one, they already had it in its factored form. They just simply said, if you read the directions, and if you missed this one, you probably didn't read the directions. It said, find the values of x that will make each expression below equal to 0. That means they gave you this, but they wanted it in the directions to be equal to 0. They want each one of these to be equal to 0. If we wanted this one to be equal to 0, this factor here, then x must be a positive 9. A positive 9 plus a negative 9 would make it 0. So this one must be a positive 9. If we wanted this factor here to be equal to 0, we have a positive 1. X must be a negative 1. Negative 1 plus 1 gives me 0. That means that this one would be equal to 0. Okay, so maybe you overthought that one. All right, the next one that was missed on this was 14. All right, this is old stuff. Maybe you're already forgetting the things that we've learned from a few months ago. But this is just simply fractions being on both sides of the equal sign. Okay? Since we have fractions on both sides of the equal sign, we have two ways to handle those. We're being added together. Fractions are all being added or subtracted. We have two methods. We call it the old way and the LCD way. Old method and new method. So you have to choose. Remember, if there's an equal sign involved, I want you to use the LCD method. That means you're going to find the lowest LCD, and you're going to multiply each one of the terms by that LCD. So we probably need to just spread this out a little bit so we have a little room to work. Make sure I write that down correctly. So then you start thinking about what the LCD of this is. We have a 2. We don't have anything, so that's really like a 1 there, right? And then we have a 3. So you look at all of those, and hopefully you would come up with the LCD of 6. The LCD is 6 between these 3 numbers. Remember, we have to include all the numbers. We're just lucky there's nothing here. Then, when you find that LCD, each term gets multiplied by that LCD. Okay? Whatever it is, each term must be multiplied by it. After we've done that, we're free to do all the little cross cancelizations that we might want to do. So you go through here and you look. Well, 2 will go into itself once. 2 will go into the 6 3 times. Nothing else I can do on that one. And you can cross your ones out. Are they going to help you? And then over here, 3 goes into itself 1 time. 3 goes into 6 twice. Nothing else I can do there. Now let's just clean it up a little bit so we can work with it and make sure we don't lose anything. 3 on this one, and x. 3x. Plus. Nothing here left, just my 6 left up here. My equal sign. And on this side, we have our x times 2. 2x. From here, we always make a decision about our x's. Remember, we always want to end up with a positive x. Some of you might go, we don't like x to be on the right-hand side, but that makes things more complicated if you're insisting that it be on the right side. You've got to get used to being able to work on both sides of that equal. If you pull that x over here, you would have a negative. So, of course, we don't want to do that. We want to pull it this way, but that probably freaked everybody out because that meant you didn't have anything on the other side. But that's okay. We're not done. So let's move this 2x over to here. If the x's are going this way, that means our digits are going that way. So I'm going to undo my 6. Positive 6 undone with a negative 6. And look, now I have digits on the right-hand side. These go away. These go away. Only thing left over here, 3 minus 2, is just x. And on this side, all that is left is a negative 6. So that's number 14 on lesson 83. All right, the last one from that lesson that gave people problems was 16. Now again, I want you to look at your book so that you're going to see what I'm talking about. You should be able to look at the book and see we again have fractions being added together with an equal sign. Okay? If we have fractions being added together and there's an equal sign, that means we're going to use the LCD method. So go ahead and set that on your paper. You know how we have to spread them out a little bit so we have some room to work. So go ahead and do that when you're writing it down. So here's my 5 over 2. And I know you don't like having the digits on this side. You like them on the other, but that's not the way it's set up, so we're going to deal with it. 3x plus 5. Leave a space here so that you have room to work. And I didn't leave myself very much room to work either. 2x plus 5. All right, so I just spread out. This is the original. It was all scrunched up. I left me room because I know I'm going to be using that LCD method and I need some room to work. So I begin looking at all my denominators here, and I come up with the lowest common denominator. Now, by this point, everybody should know how to do that. If you can't figure that out, you need to see me. But you should be able to look through here and come up with what the lowest common denominator is and see it's 2 times the quantity x plus 5. Each one of the terms gets multiplied by that LCD. Okay, there's the first one. Kind of messy, sorry. Okay. Now that we're ready to work, we're able to start marking out anything that can cross cancel out. I hope y'all can see that. I hope it's not too small. I'll try to write bigger. The 2 and the 2 will go away on this one. Actually, I wrote it twice. Sorry, guys. Yeah, that's what I want to keep. I'm going to take it off of that one. I wrote it down twice, guys. Sorry. So the 2's will cancel on that one. That leaves me 5 times the x plus the quantity of 5 here. On this one, the whole thing cancels with this whole thing. That leaves me just the 3 up here. There's my plus sign. And on this one, the x plus 5 cancel, leaving 2 times 2 is 4. So that big old messy thing just turned into this. We can go ahead and do our distribution here. And go ahead and combine our terms on the other side. And from here, it's just a regular problem that needs to be worked. And when you do that side over there, you get negative 18. Isolate your x. And that is now your new answer. X equals negative 18 over 5. I'm trying to write extra big so y'all can see it. I hope you can. All right, 84. I only had a couple questions on 84 to be worked. Again, let's see, the first one that needed to be worked is number 16 on 84. Let me write on the figure for you. We have x plus 1 squared plus 4 equals 14. Okay, before we start these, you cannot forget that we are doing algebra and we have to do our orders of operations in reverse. This is not just a straight arithmetic problem. You're not doing your powers first, parentheses and powers. If you could do parentheses, that would be okay. But we're doing algebra. We undo in reverse. That means we do the easiest thing first. We're looking at the other end of our order of operation. We start with subtraction and addition. That means this part has to be taken care of first, not this. So first thing off, we're going to go ahead and undo. We have a positive 4. We undo with a negative 4. They cancel out that way. Now, we have this. Okay? So now, we move again. There is no multiplication and division to take care of, so now we're back to exponents, and roots. If we want to undo an exponent, we undo an exponent with a root. We take a root of this, and then they'll cancel. So we take the root on this side. That means this root and this 2 will cancel out. They undo each other. What you do to one side, you must do to the other. If you take the root on this side, you take the root on the other. Now, on this side, we just have x plus 1 left now. And then on this side, we have to remember, I bet most of you forgot, or if you missed this problem, you probably forgot, there are 2 values for this. Remember, when we take a root of a number, it can be plus or minus. Okay, because the negative times the negative is a positive. So we have 2 roots we have to consider on these problems now. So you would take out your calculators at this point, and you would type it in your calculator, and you would get that the root of this is equal to 3.16. I believe. Yep, yeah, 3.16. That is a positive 3.16 and a negative 3.16. We now should set up two different problems. I would suggest you set them up right in the beginning because everybody forgets in the middle of working it that you need two problems, two answers to this problem now. There's my first one. There's my second one. Do both of them. Just set them up so you don't forget. Everybody works this one, and then they forget that they still have one more that have to work. It has two answers. We undo on both sides. A negative plus a negative is a bigger negative, negative 4.116. So you should have two answers to this problem. The only time you would not have two answers on this problem is if you were doing a measurement problem. And that would be in a word problem. If you were doing a word problem, then of course we wouldn't consider the negative numbers. You can't go to Lowe's and measure a board at negative 4.16. So it would be illogical to give me that as an answer. But if it's just straight math, you should always have two answers when you take the root of a number. Okay? All right. The next one on this one. 3x squared, 2x squared equals 35. Okay, we can't forget the things that we've learned all along. There's no factoring going on here. I know some people are trying to pull x's out and getting x squared times the quantity of 3 plus 2. But don't forget the very first rule is combine your like terms. These are like terms. That x squared, that means you have 2x squared plus 3x squared. You have both of those. It's like saying I have 3 apples and 2 more apples. Okay, you can combine those together. So the first step before you ever work that problem is to put these together. 5x squared equals 35. Now, we're still undoing. If you were undoing in reverse order, you would look for your addition and subtraction. We don't have any. So now we're up to multiplication and division. These are being multiplied together. Okay, you can't be taking the square of both sides yet because we're not there. You have to handle your multiplication and division first. That means you have to undo these. These are being multiplied. We undo multiplication with division. What you do to one side, you do to the other. 35 divided by 5 is 7. Now you can take that root of that x there. You take the root of this side and you take the root of that side. Now, depending on what your directions said, if your directions mentioned nothing about you estimating, you would leave your answer as a plus and minus 7, square root of 7. If it told you to estimate, that means you break out your calculators and you estimate your answers. This is an irrational number. It's not an even number. You can't get, it will multiply to itself. So on this side, you get your same number. You get your x that comes out of the little house there. You type that in your calculators and you should get 2.65. And remember, that's both a positive and a negative. If you don't give me both, I'm going to take off. If you feel like you need to write it both ways, then do that. You could do this and that. But because I'm not making you write the whole answer twice, I am requiring you to show me both the positive and negative. If there's nothing there or only a positive, then I'm going to mark it wrong or mark points off. All right. So then the last one from the homework that was asked to be worked is number 18 on that lesson. So hopefully at this one you could kind of figure out what you're supposed to be doing here. We have a binomial here. Remember I told you GCF is usually a good way to factor those binomials, especially at this point, especially if it's equal to 0. We're going to get some that aren't equal to 0 anymore, and we'll have to come up with something else. But right now we have a binomial. Binomials, you think of GCF, see if it'll work, and it does here. Again, you're going to look between the two coefficients, find the biggest one, always check to see if the little one goes in the big one, and it does. So it comes out. Then you look at your variables, the biggest one that will go into both, x. Set up your quantity, something times something, and ask yourself, 7x times what to get x squared? We need another x. 7 times what to give me 49? 7. We already have the x, we're done. This is something times something equals 0. Again, we know that in order to get 0 as a product, either this factor or this factor must be 0. If this one's going to be 0, then x must be 0. And if inside the parentheses is going to be 0, then we need a negative 7 to get that. Okay? So that's just how that works. All right, so that is all the homework questions I got. So I'm going to pause the video. This is going to be labeled as the homework. I will then go on and do the lessons 85 through 89 on a different video. So see you in a few.